see that we're talking about sum of angles that gives 180. From what you are seeing right here on the board, we are going to talk about different angles that when you sum them up, it will give you 180. It's very simple. We need to know some angles that you add up that will give us 180. I will start with the angle on a straight line. The first one is angle on straight line. Angle on a straight line. What we are saying here is that when you sum an angle, if you check your protractor, you will see that it's just like an half of a circle. It's giving us the total angle in the protractor there is in your mathematical set is actually 180 degrees. You can see that is 180 degrees. Angle on a straight line. The meaning of this is that if we divide it, maybe here is x, here is 120. What we are going to do here to get x, which is the unknown angle, is going to be x plus 120 equal to 180. And you give your reason. Your reasons should always go alongside when we are dealing with angles. If you are taking any decision, if you don't put your reasons, then you are not done anything. Angle on straight line. Your reasons should be there. So you can see from our simple equations that I have posted in my videos before, you will just know what to do here. Collecting like things where x becomes 180 minus 120. X is simply 60 degrees. So it is this simple. This is a primary school work, but some other times, some point in time in our calculations, we make use of them when we have calculations. So this is exactly what we are talking about, angle on a straight line. There are cases where we may decide to, it may even be, the angles may be up to 3 or 4. That is not our problem. For example, if I have something like this, maybe here is even 30, and here is, let me say, here is 40. The same principle applies. What is happening there is that you are going to add up everything sum up, in as much as it's on a straight line, we are going to say is equal to 180 with our reasons. If you don't give your reason, then the examiner who is marking your work will definitely deduct your mark. Let me give other explanation to this. We also have, sometimes people get confused because they are used to horizontal lines that is only when it's on a straight line. A straight line can be like this. The major thing you need to know is that it could even be vertical. The major thing you just need to know is that the angle is actually on a straight line. It could be angle like this, it could be angle like this, it could be angle like this, where all you just need to do is to trace the angle and ensure that it's actually along the straight line. That's all you need. Then you do your calculations, you add up all the angles to sum up to 180 with the reasons. Don't forget, that will be along with your calculations. That is the first one. Then the second one I want to talk about is, angle, sum of angle of a triangle. Number 2, sum of interior angle of a triangle. Sum of interior angle of a triangle. What we are simply saying is that whether the triangle is a right angle triangle, whether it's a scaling triangle where all the lines are not equal, whether it's isosceles triangle, where we say these base angles are equal, whether it's equilateral triangle where all the sides are equal, equilateral, all the sides are equal. All what we are saying is the interior, the inside, interior, English, interior, the inside angle. When you sum everything inside, the angles inside, it is equal to what? 180 degrees. That is what we are saying. When you sum all the angles inside, it's equal to 180 degrees. Let me just give you a simple calculation of what I'm talking about. Let me say, for instance, like they normally give questions. Here is S, here is 40. And if we have something like that, you will just do something. What you do is that you do your sum S plus 40 plus this symbol means 90 degree. The sum is equal to what? 180 degree. Your reason should be there. Angle on straight line. Angle on straight line. You should put your reasons there. We have done the calculation. It's as simple as this. You now say S plus 130 equal to what? 180. Where we now say S is equal to 180, simple equation. It crosses the equality sign. It becomes 180 minus 130. Maybe I need to bring it up. Let me take it here, the calculations. Let me bring the calculation there. Let me take the calculation here. So let me solve it here. So a question like this, what we are saying is, in essence, is we are saying S plus 40 plus 90. This symbol means 90 is right angle. We call it right angle. So when we sum it up, will tell us that, remember the law, that the sum of the interior angle of the triangle is equal to 180. You will now give your reasons. Sum of interior triangle. We only use this symbol for that. Sum of interior. You don't need to write triangle. Just write that symbol. They will understand. Sum of interior triangle. So what we are going to do now, we now say S plus 130 equal to 180. This one will cross equality sign in simple equation. S becomes 180 minus 130. That will give us 50 degrees, meaning that our S is actually what? 50 degrees. So this is exactly what we have for simple equations, for sum of interior angle of a triangle. So we talked about the first one. The first one is actually the sum of angle on a straight line. Then the second one we're talking about now is the sum of interior angle, inside angle, interior angle of a triangle. Then the third one I want to talk about is where we have corresponding angles and majorly corresponding angles. In my previous video, I talked about corresponding angle. Corresponding angle can only be gotten when we have two parallel lines that can never meet, we call them parallel lines. We have two parallel lines, then we have a line running across those two parallel lines, at least two parallel lines. The line that runs across them is called the transversal. That line that runs across two parallel lines is called what? The transversal. Now we have one angle inside and one outside along the transversal. So what we are having here, for what we have said earlier, is that S is equal to Y. S is equal to Y. The reason is what? They are what? Corresponding. You don't need to write anything. When you write the word corresponding, you know that corresponding angles are equal. So it's already known that S is equal to Y. But in this case, I'm talking about supplementary angles. Supplementary angles. Supplementary angles are two angles that you add up. Supplementary angles are two angles that you add up to give you 180 degrees. Here we are going to see it in this calculation. You see that in this supplementary angle, we talk about corresponding. That's the way I'm going to. Now you see that one angle is inside, both of them are inside, but along the transversal. Both of them are along the transversal. So what you are going to do is S plus Z equal to what? 180 degrees. S plus Z equal to 180 degrees. So what we have is S plus Z equal to what? 180 degrees. So this is exactly what we're talking about. So you must give your reason. Your reason is what? They are what? Supplementary angles. supplementary angles, what you are having there. So you are going to see that your reason is that there was supplementary angles. We have both of them along the transversal and they are inside in the parallel lines along the transversal. So we talked about this in our previous video. So this is what we're talking about. Then the next one I want to talk about is the fourth one. When we sum angles that gives us 180 degrees. In that situation is one of the circle theorems, where we said that the opposite interior angle of the cyclic quadrilateral, quadrilaterals are plane shapes with four sides bounded by four straight lines. Quadrilaterals are plane shapes bounded with four straight lines. And don't forget, we have 6 quadrilaterals: rectangle, square, rhombus, kite, parallelogram, trapezium, and I think that's the most. There are 6 of them. Now, if we find them in a circle, we'll call that theorem the cyclic theorem so this, and what the law is actually telling us is that, what the theorem is telling us is that the opposite angle, they are supplementary. Here is x, here is y. So what is telling us that, remember, it is not a quadrilateral that stops halfway. The quadrilateral must touch the vertices of the quadrilateral, the vertices must touch the circumference at 4 points. It is not the one that stops halfway. Quadrilateral that touches the circumference, it is where the theorem is used. Some people make that mistake of seeing a quadrilateral and start applying the principle there. No, it is when it touches when the vertices of the quadrilateral touches the circumference of the circle. I talked about circle in my previous video. If you don't know this part of circle, you can learn that from there. Now, what we are saying in essence here is that x plus y is equal to what? 180 degrees. The reason is also opposite interior angle of the quadrilateral. So opposite interior angle of quadrilateral. So you can see opposite. The reason for our conclusion is a theorem that opposite interior angle of the quadrilaterals, the sum of opposite interior angle of the quadrilaterals is equal to what? 180 degrees. So from all this, you will see that the cases where we sum up angles that give us 180, we'll talk about them, if any, maybe in our subsequent video we'll still bring them. So we'll go to other aspects as we come up in our next video. Always do well to join us. I believe that if you follow these videos that I'm posting, this time become a mathematician. I can assure you without any iota of doubt.